And second, I'm going to give away 4 of these Lolzbot Mini 3D printers to you, my viewers and patrons at the end of the video. Thank you for helping me get there. Now let's make the ladder. According to historians, Jacob used this special ladder to ascend to heavens. Well, naturally, of course, if you are too unfortunate to touch this ladder, you'll die. Because it's made of very high power, high voltage, low frequency across 2 metal rods. But unlike the legend, it doesn't guarantee you'll go to heaven. Unless you have led an honest life, have been good to your neighbors. Fine, I don't know why they call it a Jacob's ladder, and I don't care. We need high voltage, and I can create it with my microwave oven transformer. It creates over 2000 volts. Now we need to shape 2 wires and connect them to the transformer. Hey, I just came back from future to warn you one last time. You are banned to do this high voltage experiment at home. It is more dangerous than having an agitated cobra around your neck. At least the venom takes a while to kill you, but this doesn't. In a Jacob's ladder, we have 2 wires like this connected to high voltage. The arc is created from the shortest gap and rises all the way up. The reason is that the arc is hot, so the hot air pushes the arc up. I connected my wires to the transformer so we can see the arc. Oh, I think the gap between the wires is a little bit too wide for the 2 kilovolt to jump across. Ow! Almost killed myself. But I was saved with sheer luck. See, my right hand touched the wire first, which shocked me back to my senses. If both my hands touched the wires at the same time, now you would be watching a few hours of my corpse cooking to perfection. I'm pretty sure that doesn't meet YouTube guidelines either. Maybe I could have posted on Live Leak. So never get too comfortable around high voltage and always wear protective gear. See, even though only one hand was touching the wire, and fortunately I wasn't touching earth or any other conductive surfaces, it still zapped me. Always remember, any conductor like your body has parasitic capacitances to the environment. So if the voltage is high enough, there will be high enough current to zap you. Let me show you. See, this probe is not connected anywhere. But when I bring it close to this wire, it'll arc. You hear it? Maybe if I make the room dark, you can't even see the arcs. You see them? The probe is still not connected anywhere. If it was, the arcs would be huge. For around 2 kilovolts, I need around 1 millimeter for the arc to jump. Anyways, for around 2 kilovolts, I need around 1 millimeter of air gap for the arc to jump. Let's try it. My puny wires melted. I need thicker wires like this so they won't melt. Let's give it a try. Come on. The breaker popped. Damn it, I just want to celebrate. Apparently the 1 millimeter air gap is too short for the arc to rise. I need to widen the gap. But then that means that I have to have much higher voltage, which I could make using a simple circuit like this to increase the output voltage peak to double. The problem is that the capacitor I scavenged from my microwave oven is broken, and all I have are these 100 picofarad high voltage capacitors, which limit the output power a lot. Let me show you. Here I have a single capacitor series with my power supply, and you can see that around 1 millimeter the arcs start jumping. Now all I did is that I added the diode I talked about earlier, and we can see that the arcs can jump from a much further distance. This is too weak for Jacob's ladder though, because as soon as I open the gap it stops going. We need more power to be able to stretch the arcs, see? For a wider arc, we need more power to create and maintain a longer ionized air channel. So I guess I can keep the gap wide and then stretch an arc across it manually like this. It's a manual Jacob's ladder. I think it still needs more pizzazz. What if I put a capacitor between the rods so that when the arcs reach them, the capacitor blows up for some firework effects? Here's the capacitor. Ready? Oh, the capacitor legs melted, but the capacitor didn't blow up? Is anything gonna work today? So much power melted the legs, but the capacitor is not even bulged. Let me check something. That's why. It seems like the high voltage dead shorted the capacitor internally before it even had a chance to heat up and blow up. Worst celebration candle ever. Hey, what if I put some matches between them so at least they set on fire? I'm holding a match there. Let's give it a try. Whoa, 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 whoa! Breaker. Fire. Fire creates plasma. Let me introduce you to fire. We don't need high voltage after all. Breaker. And what if I add some sparklers to it? It's getting there. Oh my god! Oh! Yay! Let's make it fancier. I designed a stand for my fancy Jacob's ladder and I'll print it. So I'll be giving away this Lolzbot Mini 3D printer. It's a pretty solid printer. I've had it for over a year now and printed a few things with it. Very useful tool to have. It is a two-piece part which I'll glue together like this. And I'll drill the burrs out of the holes. And so we have a shrine. I leave a link to the 3D model in my website in case you need it for spiritual reasons. Of course you didn't think I was gonna use these tiny sparklers, eh? Say hello to my 28-inch sparkler. Put them in. Let's add a bunch of more tiny sparklers to it. Let's start the mayhem. The hell? The hell? Why bad things happen to good people? Come on. Ooh. Sheer luck! Thanks to my flimsy wire connections to the transformer that fell off quickly, I only sustained some third-degree burns. My stupid long sparklers made my structure top-heavy, which of all people fell right on top of me. I leave a bunch of safety tips on my website, but such experiments are not worth dying for, so don't do it. Let's just celebrate like normal people with oversized sparklers. Yay!
Una friera min amore en camermiana min amore anta gugliora me cafo eta con mi Roma se d'amore Ana maniro O come rite vanagnore Antariziero stava frera vanannero mo amore Nava fuero Amore, sé que cinta amo feri tabo Giveaway time!
Hey, I survived 1 million subscribers and hopefully I'll survive another million too. And to show my appreciation to everyone who made this happen, I thought giving away a few 3D printers is in order. Lulzbot makes some top-of-the-line printers. I've had this Lulzbot Mini for a while now and I'm pretty happy with it and I thought you deserve the same. So I give 2 of these to my patrons at patreon.com who are automatically in the draw and the other 2 go to the viewers. So like last time, if you have a need for a 3D printer, leave a comment so I know you need it. Something like lols my butt Lulzbot. I don't know, be creative, bring smile to my face. And thank you again. Hi! Electro Boom channel finally reached 5 million subscribers, all thanks to you! If it wasn't for you liking my videos, I would be probably at the corner of some lab sniffing solder fumes. Now, I just sniff solder fumes at home. So thank you! And it took us a little bit less than 10 years. So now we have to celebrate with a great project and a massive giveaway of 4 3D printers thanks to Lulzbot for providing them. A Taz Psychic, a Mini 2, a Taz Workhorse and a Taz Pro S. Watch to the end if you want one. Do you remember my high voltage DC magic wand I made a while back? Now I want to make a super high voltage AC magic wand. Basically, I want to make a portable Tesla coil, which is quite simple. All we need is a piece of wood like this as the handle of the wand. Then we just need a tad bit of duct tape to connect our Tesla coil to the piece of wood. And there we have it. There we are. Let me increase the power. Ho, ho, ho! Increase the frequency. Oh yeah! Look at this. It's beautiful. Now I have a magic wand. Alakazam! Too much noise. I'll do voiceover here. What the hell? My thing just turned on. What is going on? Why is my table rising? Oh, ha ha ha! I have actual magic powers. Come on, stop. My god, you little buffoon. I'm joking. I'm going to make a proper magic wand. I feel like I might be making a failure.
Which is probably something my parents said when they were debating about having me. No, what really? These magnificent arcs require such dimensions and big circuits, and to fit them inside a tiny magic wand sounds impossible. Well, let's try it anyways. We may not get any magnificent arcs, but we can at least make the wand beautiful. Well, let me explain the plan to you. Well, I was thinking, I bought one of these touch monitor thingies that you can draw on. Maybe it's time to replace my stupid whiteboard. Although I don't want to lose the whiteboard. It has nostalgic values. Let me see what I can do. I'll wear my green shirt backwards so it's blank and comes all the way up my neck. I use my Elgato green screen. Set up my drawing thingy here. And I'll pop a headless picture of me on the screen. There we are. And now I can draw anything I want on the memory of my whiteboard. Okay, so a Tesla coil is generally a pretty bad transformer. And it's its badness that makes it great. With a primary coil, a secondary coil, and a big metal toroid on top called a top load. The large metal top load creates a parasitic capacitance to the environment and earth. And of course the secondary coil has an inductance. And together they create a resonance frequency. And Tesla coil is a transformer that works in resonance mode. So this means if we actuate the primary at the same resonance frequency as the secondary, the output energy builds up over time, creating huge voltages. So you see, the resonance frequency is dependent to the inductance and capacitance of the secondary. The larger the top load, the larger the capacitance, and the larger the inductor, the larger the inductance. And this poses a problem for our magic wand. See, we are restricted by the dimensions of our magic wand because, well, we want it to look like a magic wand. See, the secondary winding will be thin and long, and the secondary top load can only be a tiny ball. And I guess the primary coil will be very tightly wound around the secondary, which is bad too. So basically we have a small inductance and a small capacitance, which will both contribute to a much higher resonance frequency, and it makes it much harder to drive the circuit. Well, let's make the coil itself and then we'll see if we can drive it at all. So here's the plan. First, I will 3D print a thin and long pipe to use as my secondary. For ease of printing, I designed it as two separate half pipes that I will glue together. Save my model on USB and let's start printing. Wow, I put off using it for so long. I thought it would be much more complicated to use. But it's so easy to set up and run, and it's noiseless compared to my last one. I guess I'll see you in 15 hours. Finally. Now we carefully try to peel it off. Have to remove the support structures. And now we chop it and put it in the salad. Then we glue the two pieces together using crazy glue and hold them together with tapes while they dry, like so. Then we remove some uneven edges and sand it to make it as smooth as your brains. Apologies. Then I'll 3D print a tiny piece that will hold my top load ball. I bought some steel balls, I just need one of them to use as my top load. Here it is printing. A beautiful art is a result that will tightly hold your balls and goes to the end of the rod. Apologies. Then I'll wind my secondary coil. I use 28 gauge wires for over 700 turns. Then I place the ball holder on top and pass the end of the wire through it and connect the wire to the ball somehow and then glue the ball to the holder. Here I'm using a spring connected to the end of the wire, then I use crazy glue and push the ball against the spring and hold it until it dries. Then we need to wind a few primary windings right on the secondary, which frightens me. The reason is that the primary windings are at much lower voltage than the secondary, so it can easily break through the insulation and arc between the wires. So I have a plan. I am going to 3D print a container to put on the secondary and fill it with epoxy. And hopefully this additional layer will provide enough insulation between primary and secondary. Here is the part being 3D printed, and I put the two pieces together and weld them together using hot temperature, like so. And then I fill the part with epoxy and let it dry. And while I'm at it, I epoxy the secondary too for protection and electrical isolation. And I guess here the table is getting a free coating of epoxy too. And then I'll rotate it for hours until it dries evenly. Now we are making the primary winding, bending it into shape using 10 gauge wire. And I bend and form. I didn't come all the way from Iran to state the obvious. I put it on the place, I guess. Then I use the wire jackets to create insulation for primary so that its wires don't touch each other. Like so. I think that was smart. Now there's a typical problem with Tesla coils that if you look right there, a lot of magnetic fields don't pass through the entire length of the secondary or at all. This means you have poor coupling between primary and secondary windings, and you have to create a ton of reactive power in primary so that some of it converts to real power in secondary. Now reactive power is not a waste in itself, but to create it you have to generate a ton of waste over the driving components. And that's when generating a ton of reactive power becomes a problem. The reason for this bad coupling between primary and secondary windings is that, unlike other transformers, Tesla coils don't use ferromagnetic cores and only use air core, which is a piece of junk when it comes to cores. The reason we use air core is simple though. If we actually use a conductive ferromagnetic core for our Tesla coil, because the voltage across the secondary of Tesla coil is huge, having such conductive core places super high voltages very close to each other, and so the voltage will arc through the insulation of wires and short the coil. I did see this when I was running my Tesla coil in vacuum, which melted my secondary, all because I accidentally ran a screw too deep inside the secondary. I was holding my top load with a screw that was going too deep inside the secondary, and the voltage between these two parts was high enough that in vacuum my screw arced to my winding and melted the whole thing. But my dudes, I may not have much choice. The inductance and capacitance here might be so small that the resonance frequency would be too high to be easily drivable. If I use some sort of ferrite core, I can increase my inductance, which in return reduces my resonance frequency. Easier to drive. Not only that, a core will focus the magnetic fields inside the secondary and further up the winding, which means a larger energy transfer and hopefully a much larger voltage. But of course, we have the problem of shorting high voltage. So here's the plan. I bought a bunch of short ferrite beads. I will place these beads at a distance of around half a centimeter to each other, and then I will encase the whole thing in epoxy. The goal is that not only this is not a continuous core, so it doesn't place super high voltages close to each other, but also all the gaps between them and around them is covered with epoxy that should provide a very good insulator against high voltage arcing through it. I'm using a clear sheet to create a mold for the epoxy and the beads, like so. Then I use a two-part epoxy. I pour equal parts and mix them until clear. And then I put them in a vacuum chamber to debobulate. Then I pour the epoxy and place the beads inside. Then I space them half a centimeter, and after drying, look at the beauty that comes out. But we are not done. I'll print a mold for the epoxy because I want to make it even thicker. I place my rod inside and let it dry. Then I take it out of the mold by melting the mold. We'll find the shortest path. And we can start welding. Ow! Let's stick a knife in a toaster and see. Don't stick a knife in a toaster. Here's a toaster. We turn it on and let's see what happens if we shove a knife into it. If I turn on the toaster, if we shove a knife into it. If I turn on, and let's see what happens if we shove a knife into it. If I turn on the toaster and try to short it, oh, it popped. It won't cause an explosion. An electric heater is just a resistive piece of wire that heats up when electricity passes through and two electrodes with high enough voltage difference to break the water molecule. not a continuous heater wire with a molecule or drop of water on it. Wow! It's okay, darling. They apologize. Why is this still plugged in?
The fuse box should be somewhere in there.
That's why we need proper control electronics like this electronic control unit or ECU to run the motor. Control unit or ECU to run the motor.
It's finished.
Okay, Y configuration and trying one more time. Oh, well, I'm done with this. Clearly, I can't make strong enough magnetic fields to make this garbage turn.
That's why you have to use a glove. Bring your car down slower.
As I mentioned in my other video, a power supply like this one that can generate 70 amps doesn't necessarily hurt you at all if the voltage is set very low. Observe.
No! Who the hell set this to 25 volts?
Let's reduce the voltage level and increase the frequency all the way to 60 Hz. I shocked my ass sitting on these live wires. Always clean up the lab, otherwise something will bite you in the ass. Holy! The camera is okay. It was very dangerous. I almost burned the place down. Oh my god. Okay, finally, let's power it up. It's done. Let's turn it on and see how it looks like. These lights won't fit my light socket, so I'll connect them using my alligator clip. You shouldn't forget to turn the light off or open the breaker before working on your electricity. Let's measure the current. You never touch the live wires. I'm what you call a professional dumbass. Now let's try the same thing with a regular light bulb, although I can't see the LEDs well. What is it? Plastic? What is this? Titanium? Whew, here we are. Now if I touch the ground, what? Ow! That's it. No more using my body as a capacitor. For sake. It's much more dangerous if the current runs through your body first, then into the water. Let's try it. Ow! If I short them, there is no current running between them and the probe ground is connected to earth. Why do I keep forgetting? This can tell you tons about what you're measuring. For example, if I measure the outlet voltage, ow, never handle live voltage. I'm a professional. One to measure the input and the other one to measure the output. God damn it! Let me explain. Ow! Like a microwave oven, for example. I can put in there like a plastic fan. I guess it's not going to heat up because it's plastic. Now if I turn it on, it draws power from the supply to heat up the How does it work? Wow. If there is metal in something, don't put it in the microwave. Just burn my #1 fan. We can use a lamp, for example, as the load. Here's one way for $1 or $2. Never try this, of course. Very dangerous. It is illegal to destroy other people's properties. But this is my wife's computer. Mine, hers. What's the difference? It's gone. Very effective. Now it's ready to go. You just plug it into the power line. It charges right away and you can unplug. Then you charge. I bought this novelty gun from my local dollar store, and when you press the trigger, why? It zaps you when you press the trigger. A very cool trick to end a few friendships. Yeah, I'm doing so. Does it mean I can get shocked with a single AA battery? Ow! Ow! That went through my entire body. Let's see how badly it shocks. I hate getting shocked. Ow! This is pretty painful too. Let's try it one more time. Ow! Ow! I hate it. Here I have a loop of wire connected to the live lines close to a magnet. So when I plug it in, it should turn or vibrate.
It's out a powerful signal.
What is that giant deal? Oh. Did the guy really think that his giant dilemma? And there is not much current through my body, and I bring my other hand close to the tower and it's... Ow! It seems I've passed over 100 milliamps through my body that heated up and burnt my skin. Okay, it's definitely shorted. Let's plug it in. Hopefully nothing will happen and I'll know. Oh jeez. Wow, I better clean it up before they see it. North American GFCI trips at around 5 milliamps, so let's try a 47 kilo ohm and see if it trips the RCD. Never use your bare hand. What did I pop? So if you use this to power your devices, they will blow up, although nothing should happen to the transformer itself. As you know, a speaker is a magnet and a coil that when you excite the coil with an AC voltage, it vibrates at the same frequency. You tie its input... Ow! Well. Ooh, these metal doors are perfect. If I can find one without the handle. Died again. What's going on there? Something... Ow, shit! Hello, FBI agent?
What?
This is for educational purposes only.
Is it now?
Yeah, just watch to the end of the video before swatting my house.
Okay, I'll wait.
Okay. Oh, by the way, do you swat Canadian residents too?
We do.
Yeah.
Of course, heat is the enemy of permanent magnets because the structure shakes out of alignment and the magnet dies forever. There. So don't overheat your magnets. Goodbye, love. A capacitor stores energy in form of electric fields between electric charges and can later release them when a load is connected between... Damn it! And just like that, you can charge a capacitor. Of course, it only takes a fraction of a second to charge, which depends on the amount... Did I connect it backwards? I think I did. Okay, let's check this pipe. Ow! Okay, let's check the toaster. Ow! It's not grounded either. You simply plug this into the 120 volt and plug your hairdryer in and turn this on. Oh, ow. You can borrow our hairdryer, you know. I don't need it. Yeah, this is the only one that does it for you, eh? You know, you just look fine the way you are. I'm sure we can find something similar. No, I didn't buy my degrees. I know how to make it work. Fine. Hey. This is the oven outlet. The voltage reading here will show us if the phases are 120 degrees out or 180 degrees out. Let's check. Holy piece of... The meter was on current. Always make sure it is on voltage before you measure voltage. design of the outlet, I can pull it back a little bit and expose the high voltage lines. Let's see what voltage we... Ow! What the f was that? Stepped on stupid spaghetti down here. I have to clean it up. Okay, let's do it. You just bought a new one, eh? I thought this was the only one. Works even better. I did find you the perfect solution. Hi, did you know that we live very inefficient lives? For example, only around 50% or less of the available hydro, wind, solar, gas and coal energy gets into our home as electricity. Only 5% of which current meter series with the AC line to measure the current. Shorten. Let's give it a try and see how it works. Wow! And now the relay can turn on a light too. Hi, AC motor is a founding father of our modern society. Without it, we would fall back to the steam engine dark ages. People suffering in cold mud. If I short them, there is no current running between them and the AC. The probe ground is connected to earth. Hi, I want to make a I said shunt! A piece of 22 gauge wire here, which I'll measure the voltage across. If I connect it to the output of my auto transformer, I should... And burn my fingers again. The piece of wire, let's see if it can do the 100 amp now. There. 77, ooh, starting to smoke. Come on. 80, oh, melted again. We need, you can clearly see that the yellow current line is leading the voltage green line as should happen in an inductor. Why the f the current is not a sine wave? Pah, there, it says the current should look like that if you're using an iron core, because the iron core doesn't have a linear magnetization. The whole seat is melted. Oh! In high, I can even turn on an LED through the water. Ooh, the breaker open. See, now the voltage reading here is actually showing that there is 1.8 amp running through it. It's burning now. Of course, it simply shorts the AC output. So I start at 0 volt and slowly raise the voltage while I'm measuring the current with my clamp meter. Let's see. Oh, I'm starting to think coming up with the idea of a light bulb didn't require much genius. Well, that was super painful. No, see, the mouth and the lip area is more sensitive to heat. It's slowly getting warm, but it's not too bad, so it should be fine. An brilliant idea may change the world. Got to unplug this thickness. Unfortunately, I'm in luck. I have some 8 gauge wire, which is around 2.1 milliohm per meter. So I would need around half a meter of this for 1 milliohm or 0.1 volt per 100 amps. It's safe to touch. Ow! Of course, getting shocked is not the only concern. Obviously, this thing is a heating element and can get very hot even if I run it on 120 volt AC. And it's pretty uncomfortable to sit on anyway, so I went and bought some. If this can't do 100 amp, nothing can. There we go. Let's see. There you go, 100 amps. And it's holding on pretty. Oh, my auto transformer can't take that much power. Hi, I have a great and unique idea, which is turning your wooden or plastic seat into a heated seat so your fragile buttocks can rest in peace. All we need is a heating element, which I'll extract from this broken hairdryer as these wires. So here we are. I hot glued these wires to my seat with their end connected to a cable where I can just plug into the wall. Okay, there we are. Where the f is it? Site, mounting a heating element with hot glue is a pretty dumb idea because the glue can melt and stick somewhere else. And also evidently sitting on super hot live wires is a terrible idea, as my butt can confirm. Where are you? But we other heating elements. This one is pretty small. Maybe you can use it to heat a baby, or as intended, electric charcoal starter. Don't use it on babies, you idiots. Kind of similar. Using 2500 volts, I need a very small gap to get the arc going. But after I create the gap, I can maintain it with lower power over a wider distance. See, this is very dangerous. Never try this. Just watch. There's no opposing fields that repel each other and the ring jumps up. So here we are. I place my loop on my coil and I run 10 amps through it. And the disappointment ensues. Just does a tiny wiggle. I think we need more current. Fine, I'll use my super capacitors to run 100 amps through it. Okay, the capacitors are charged to 20 volts and watch the ring. Ow. Ooh. Ugh, my coil totally melted. I will. But this one is pretty nice and fits my seat well and is made for 240 volt 3000 watts, which is very similar to my oven element. Like a regular light bulb? That's odd. Okay, let's try it. I have my 120 volt AC live wires here and I'm just gonna connect. Handling live loose wires like this is quite dangerous. So I tied one side to the filament and I'm gonna carefully touch the other side of the filament. You know what? This. Never handle live loose wires. Always turn off the breaker, make all your connections and then turn the breaker on. Okay? Let's turn it on. Oh. It wants to keep up. Come on. Seems like the 120 volt doesn't want to keep it on. Likely because the filaments are blown. I guess I have to find another way. How come my breakers are not popping? I literally have 4 breakers, 10 amps in series. Let me switch to my longer spool. Maybe I can run it continuously. Holy shit. Look! My 100 feet of wire melted! So eddy currents can be pretty cool and useful, like in an induction cooker. The cooker radiates very fast changing and strong magnetic fields that create huge eddy currents through a metal plate. If you use a high resistance metal plate like iron, as they use in some pots and pans, it generates a lot of heat. Wow, it's getting glowing hot here. But in a lot of cases, eddy current can be pretty bad. Ow! Which makes me wonder what is the difference between this new dimmer and old ones. We have one of these old dimmers. We have this old dimmer which I'll try to probe using my 4-channel awesome new Keysight scope, which I'll also give away 5 of them at the end of the video. One to input connects to 120 volt AC and at the output it generates around 2500 volts which I'll connect across the lamp. Something tells me this is not the right setup, but whatever. What you have probably seen as an effect of eddy current is that throwing a magnet through a copper pipe slows the magnet down. This is paper though. I didn't bother buying a copper pipe just to add it to my collection of unused pipes here. Or to go through the coil. There. I'll use my wrench handle for that and then I'll just power it from 120 volt AC. Okay, here we are, and here's a ring, if you can see it, and whoop. Oh, it did jump. Hey! But look at that. See, what I've done is that I cut the housing and removed the glass, and I also glued a piece of wire here to the housing that can move now. And normally this needle could move freely when the temperature rises. But now, as the temperature rises, the needle gets stuck to this piece of wire. So the temperature can't rise anymore because the needle is stuck. Is that how it works? Because, I mean, the needle is stuck, but the temperature could be rising. It's just not showing it. I think we need to do better. Here, I did.
But how do I make my wireless link? Maybe I link with 2 Bluetooth modules, or maybe 2 Wi-Fi modules so I can link multiple transmitters, or maybe I come up with my own mystery wireless link. Let me see if someone will sponsor a free sample. The good systems are usually expensive. There are a lot of companies out there that make this cheap though. I have the circuit on the breadboard. Let's power it up. I created a light bulb. Obviously there's a wrong connection.
Drive it, you just stick it to a DC voltage. Hey, calm your shaft. I said calm your shaft. Why do you have to keep it exist?
Let's run a single tone with a lamp on. This is loud.
Anyway, I bought my own power saver from Amazon. This one says Intelligent Energy Saver. The result is the best. So there must be some smarts in it. Let's cut it open. Well, there is an LED and some resistors in here to indicate that you have plugged it in case you're deaf and can't see that you have plugged this giant break into the wall. And then a good example is this AC motor I took from a microwave oven. And if you look at the current, it draws around 190 milliamps. And if I connect the capacitor, there we are. The breaker popped. It's like a video game where you only get one life, and if you lose, you have to throw your computer into garbage. That's why they call discovering new things the bleeding edge of technology. I'm pretty sure it's easy to make one at home though. All I need is an aluminum foil I wrap around my paper pipe and tape it. Now my magnet drops through air at this rate and through the pipe the exact same rate. Thanks for cheering me up. This. It's dimming my entire home lights. How much current is it drawing? How much is it? It's like 36 amps.
But I don't want to be like,
Wow, look at this product. So quality, much sound.
so I might as well aim high.
Hi, what is a brushed DC motor? It's a motor that runs on DC voltage. How to success! See how much arcs are flying off of the commutator. The amount of heat and current is damaging my contacts and glues. I should have made it better. But the commutator and brushes are the downside of brushed DC motors.
Might be better. Why does it feel different? It feels like an actual painful electrical shock, unlike my old Tesla coil.
And there is this potted black box that I suppose the brains are in here. Let's cut it open. This black box is a single component, a high voltage capacitor with a value of around 2.1 microfarad. There is no brain in this. They lied. All of them lied. Those son of a... Okay, wait. Wow, the microwave is such an inefficient piece of junk. Well, maybe in an empty microwave, most of the power was reactive, and when I put a cup of water in it, some of it converted into active power. But in any case, adding this tiny capacitor doesn't make any difference in the big scheme of things. Maybe less than 0.5%. And I wasn't paying for that current anyway. At home, the capacitor continues to draw current from the lines. And I wasn't paying for that extra current anyway. Why do they sell shit on the market? It's garbage. Oh wait, I could still use it as a novelty shocker. Well, you know what? Hi, I don't know if you have seen those stun guns they sell online. I saw channels like Jerry Rig Everything or Unbox Therapy reviewing this yellow jacket stun gun, which is a cell phone case that can output 7 million volts.
The future of self-defense.
Look at these high voltage arc generators. 400,000 volts, 1 million volts, 400,000 volts, 400 kilovolts, 500 kilovolts. False claims everywhere. Won't stop me from buying one of these babies though. I've borrowed an ESD gun and I've set it to 25 kilovolts, and I'll bring a ground wire close so that the arcs start jumping. And then I can measure the air gap using my... Right after I shut down the gun. Saying that it's not the voltage that hurts but the current is like saying I'm gonna shoot you in the head with a shotgun, but as long as the bullets hit you very softly, you won't feel a thing. Wanna try? How many times do I have to say this? If there is high voltage across your body, there is no way to limit the current and you'll die. Here, let's say this 12 ohm resistor is a human and I'll put 10 volt across it with no current limit. Let's see what happens. See, the human burns. But if I current limit the supply to 0.1 amps and put the same 10 volt across a fresh 12 ohm, and it doesn't burn, but is the voltage the same? No, it has dropped very low. If your supply is current limited, the voltage must drop. If the voltage doesn't drop, the current remains high. And that's why the signs say danger high voltage, not high current. Hi, ready? Yeah! Oh well, I missed the spot, but every subscriber is a new achievement anyway. 2 million subscribers! Thank you everyone! I've had these for over 2 years. Ow! 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 It's okay, these are just fingers. Are you okay? And truly, these scopes are... Sounds a little bit better, but it might still be the... Anyway, let me get further away from the tower so that the audio feedback doesn't get to... Hi, I completed my 1 Tesla kit assembly and I'm excited to try it together. Let's dim the lights. You should always keep a proper distance from Tesla coil. Let's play Pink Panther. My f***ing brain cells! According to their manual, it is better to stand like 10 feet away. Who knew? The flow of electrons is pushed to the outer skin of the conductor due to the electromagnetic fields generated by AC current. The higher the frequency, the thinner that outer skin becomes. This thing pulses energy at frequencies lower than 1 kHz, which means it has strong low frequency harmonics that will penetrate deep inside the body and is definitely harmful. So never try to touch this at home. I'll give away 4 of these at the end of the video so you can exercise not touching it at home. For example, most fans with AC motors don't have a capacitor in them to correct the power factor. It is drawing 0.7 amps and I have a 10 microfarad capacitor. Watch the current carefully as I connect the capacitor. The capacitors used on power lines are rated for high voltage and are not polarized. Anyway, at home, there are 2 phases coming to our home, with black one being the main one, which is providing 2.5 amps at the moment. Let's see if connecting this makes any difference. There, the current dropped by 0.1 amps. This requires a bunch of probing and design. And so thanks to Keysight, I'll celebrate by giving away 10 of these babies. Well, before completely dismantling the circuit, let's see what kind of pulses we should be making. Well, we should definitely disconnect the tower. Now ready to go. Hello? Wow! Well, the laptop screen was jumping around too. I think it's a little bit too sensitive. I have to adjust it. Hello, 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 hello. Do you hear me? Hello? 1, 2, 3, 4. Said I love you, but I lie. This is more the love I feel inside. Hello, hello. Do you hear me now? Maybe I'm sitting too
million volts.
It says it right on the box. Let's download its user manual. There it is. Yellow jacket case is a 7 million voltage stun gun. A 7 million voltage stun gun? Really? 7 million voltage? Voltage is the electromotive force or the potential energy required to move the electrical charge. The unit is volt, 7 million volt stun gun. I reject your claim based on such a simple grammatical error. No, but really, this phone case is not the only one claiming such a high voltage. Just really need them though. If you remember, I made my own taser back in my old video. The arcs can jump well. You don't bring your finger close to a stun gun when it's running. Everyone can build something like this or even stronger. Having a cell phone cover that's also a stun gun is cool and all, but are you really comfortable having a stun gun on your head while talking to somebody? I can imagine many people fidgeting with all the buttons while they're talking to the person they have a crush on. Oh, tonight? No, I'm completely free to. I don't know why manufacturers claim such bogus numbers. Here's a few of them. World's the smallest at 6 million volts. See, even the prongs are not that far. And here's a pink zebra taser with 18 million volts. What the f is this? 980 million volts? Even most lightnings don't have that much voltage. I'm starting to think there is no regulation around bullshit out there. Let's just jump into it. I have made 2 videos before showing how this thing works. It sends out 10 to 50 microsecond wide pulses of around 300 kilohertz super high voltage AC. Sending out pulses more often changes its sound. Now let's measure and see how each pulse feels. Feels like somebody is slapping me hard every second. Imagine if I change the frequency to 1 kilohertz, I'll be slapped 1,000 times a second. Pretty painful and damaging. So, I don't know, maybe the component of the microphone was more sensitive to interference. Now, do you think I can hold a knife and bring it close and don't get shocked by it? Let's try. Burned my skin. When it was jumping to the knife, it was fine, but as soon as it jumped to my skin, it burned. And although it's still quite dangerous, I can still touch it, and it's not as remotely as painful as touching the 120 volt AC. And the light bulb runs on it just fine, and it's even a little bit brighter because it's 170 volt continuous. Beside the lights, it's at 7 volts for 7 amps through the load. And because of the high resistance, it's heating up so much. Similarly, because Edison was passing low voltage across the transmission lines, a ton of current was passing through the lines. And there is a limitation to how thick you can make the wires before they break under their own weight or become too expensive. Power no matter what. 2 volts, 3 volts, 4, 5, 6, 7, 8, 9, and 10 volts across the load. We did it! And our transmission line is not burning, so that's always a plus. Nothing is exploding. What is the transmission line voltage now? $820 volts! Well, anyways, although this is a pretty bad example, you can see that I'm transmitting more power than the DC system, but my transmission lines are not burning. So that's sort of a success. See, in this system, I can transmit a lot of power, in this case around 100 watts, without having to thicken the transmission line wires. And if the transformers were in your pocket, you have to see how these things sell on the web. Comments under those, people are happy. How does it work? It's not even... See, every time your body picks up static electricity, say by walking with socks on the carpet, the only way to get rid of them is to take them and put them somewhere else, like in the ground. And it's the pointiest one they had. And then I found this one, which is much pointier. It's called the choker. And they both have metal exposed on the back to touch my skin. Okay, let's do it without the spikes first. I put my legs up. Okay, charge my body a little bit, and then discharge. Ow! That was painful. The 2 phases come to some plugs like this one that we can measure. Here we have... It is important that after you use your meter in current mode, you switch it back to voltage. Otherwise, it will short your circuits. Let's try using my Lulzbot Mini 3D printer, which I'll also give away one at the end of the video. Here is the 3D model of the stand that will hold the motors face to face. And here it's done. Oh, I broke it off. Damn it! I shouldn't have grabbed it from the fragile part. There it's done. Now if I can only pull it up without breaking it. The light bulb on AC as usual. And here I killed it. Don't short. Anyways, with this, I'm converting the AC into DC using it's a single diode, but it will do. As the electric motors were becoming more popular in home appliances like meat grinders or fans and such. But even those could be made into brushless AC or brushed DC, for example. Of course, a brushless AC motor like this one that I took from an old microwave oven can last much longer than a brush. Loose wires, avoid them. Anyways, brush. Here I'll use my auto transformer to generate 10 volt AC, which would result in 10 amp AC through my 1 ohm load. But before I send it through the transmission line, first I'll step the voltage up using my microwave transformer. And then I would step the voltage down after the line if I had a transformer. Well, guess I can borrow the one from our microwave. They're using tamper-proof screws to stop me. What they don't know is that nothing can stop me. They're just postponing the inevitable. There we are. I'll just take a picture of the wiring before I pull it out. I don't want to blow it up later. There we are. Okay, now we have both transformers. The input and output power is ideally the same, although not really, because there is always some power loss, as you saw. And power is voltage times current. So for example, if I increase the voltage by 20 times in order to have the same power, the current has to drop by 20 times at the output of the transformer and over the transmission lines. And because the power through a resistor is equal to resistance times current squared, the power would be 400 times less wasted on wires. And with high voltage comes great responsibility. The transmission lines have to be placed far enough so no arcing happens. It's when I run my Tesla coil. See, the charges go out only from the tip of the needle and nowhere else. So I thought with those punk bracelets having so many metal spikes, they potentially dissipate charges into the air quicker and drop my body voltage and reduce the risk of discharge and shock. So here, okay, let's do it with the spikes now. Okay, this time with the bracelet. 1, 2, 3, 4, 5 and discharge. Ow! That's absolutely useless. Well, maybe the dome is charging my body too quickly, so let's do it more realistically. I'm gonna force. The voltage level across each load is the same, just 120 degrees phase shifted. And if my loads are equal, meaning their effect on current draw is the same, then at this point I'll have the sum of 3 currents that are sine waves 120 degrees phase shifted, which is 0. Bam! There is no current returning to the source. 3 wires eliminated. Hallelujah! Isn't it genius? We just added 1 wire compared to a single phase AC, but we are delivering 3 times the power to what is called the balanced load. Dab on hay. If I measure the voltage at the output, holy the capacitor, piece of shit. Anyways, I'm reading around 170 volt DC line using thin wires, and using my supply I'll try to place 10 volts across my 1 ohm load for 10 amps of current, and I'm measuring the voltage across my load. Let's try it. See, the voltage is like 7.5. And you see my transmission line is starting to smoke and heat up, and the voltage continues to drop. See, the line resistance is so much that the voltage across the load doesn't even get to 10 volts. Okay, and the voltage across the load is 1.6 volts. That's garbage. What happened? The transmission line voltage 118 volts. Everything dropped. This is worse than the DC system. What's going on, Tesla? Let's measure the transformer's secondary winding resistance. It's around 100 ohms. No wonder. There's too much drop over the large resistance of the secondary. Touch the dome. Ouch! Charge my body first and then let go and then touch the ground. Ah, shit. I hate surprises. Okay, without the bracelet, charging my body. 1, 2, 3, 4, 5. And discharge 1, 2, 3, 4, 5. And now with the bracelet. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's see if they look as we expect. We just have to tie the neutral wires to the ground of the... I see. In DC systems, we usually show positive with red and negative or ground with black. This is the pulse width. There. We have three-phase AC signal. And if we increase the pulse width even more, oh, it turns faster and we get even higher voltage. AC motor like this one is enough. But in factories for high
Go on.
transmitting power in DC or direct current can have great advantages over AC or alternating current. Oh yeah, I did try to show you DC was better by electrocuting those animals. If it wasn't for that meddling Tesla and his stupid ways, now we would be living in a much better world of DC power lines. Edison, you didn't know why AC was better back then and don't know why DC can be better now, so shut up! In fact, even DC lines are much easier to connect to each other unlike AC. Let's connect two AC lines together. Here I have my car inverter running on the 12-volt battery, and here I have the CD power line. Both of them are exactly at 120 volt AC. And that's why you don't try that at home. Being 120 volt AC is not enough. See, the sine wave is coming from the CD and the square wave is coming from the inverter. They are not the same shape and they are not in phase because their frequencies are slightly different. These are falling apart under my weight. I guess I have to reupholster these myself? You know what? I'll make a video about it and post it on my new channel, Meditation. Subscribe to my new channel. But that's not the point. These stupid sockets, in fact, all our sockets in our home have lost their grip on the plugs. Anything I plug in them just slips out. I don't know what the previous tenant has shoved in them. See, it's like a limp. I guess it's not the male side's problem. It's the female side lost its springiness and doesn't grab the prongs well. Hi, I have jump-started my car with AA batteries before, but now I want to try and see if I can jump-start with supercapacitors or supercaps. As we know, capacitors hold electric charge like a battery. What's so super about these? This is a 100 millifarad 6.3 volt electrolytic capacitor, but this is a supercapacitor rated for 2.7 volts and it is 400 farads! Stop yelling at the camera! So at the same voltage, this supercap can hold 4,000 times more charge compared to this electrolytic cap. Can you digest that? Of course not. Charge. Oh, I forgot to unground myself. That was painful. No more touching it with hand. I made another grounded ball to discharge it. Let's try it at different number of strokes. I made it darker too so you can see the arc. Okay, 10 strokes. Yeah, a little bit. That looked like a 1 kilovolt discharge. Here's 20 strokes. Not bad. It was probably around 5 kilovolts. Due to the line inductances and the fast nature of the discharge, but we'll see. Okay, ready? Ow! Ow! It hurts where it goes in and where it goes out to the ground. Of course, this is much worse because its capacitance is around 5 times larger than a regular discharge a human body experiences. So the duration of the pulse is much longer, and a 5 kilovolt on this one can hurt as much as 25 kilovolt of a regular discharge. Capacity. Yeah, it's around 5 nanofarad. We are already ahead. But now we'll roll this tight. This way the layers will overlap multiple times, increasing the capacitance much more. But now that I think about it, rolling it should only bring the outer surface of one beside the outer surface of the other one. So double the surface area and double the capacitance? Am I wrong? Let's check it. Crap, I totally forgot. First I had to put the second layer of mylar, otherwise I would short the 2 layers. And from the output voltage drops. Let's look at it on the scope. I'm probing the live 120 volt AC input, and I have my capacitor and diode here, and I'm probing across the diode. Now if I connect the circuits together, right, the polar capacitors are no good for reverse voltage. We will have to isolate the circuit well to avoid leaking charges, because they will load the circuit and lower the voltage. The series, remember, even after disconnecting the supply, the capacitors still hold charge. Cascading the circuit. Here's my diodes. Now I have to solder the capacitors. Okay, here we are. Let's run it and see what we get. Expecting super high voltages. Well, that's nothing. Oh, it seems like the leakage in higher stages is so high that it's loading the voltage and it's nothing significant. And henceforth, measure the AC output using my the power line straight capacitors don't blow up like that. Let me just run it on low voltage AC. I have a 1 volt 10 kilo. See, we just need to make sure the voltage levels are the same. Right now I have rectified the 2 sources with a diode and capacitor, and we can easily connect them together. Yes, we need to make sure they are the same voltage level and the same polarity, of course. Sometimes I bend the prongs like this so that it can hold on a bit better. But let's just change this one. First, you remove the cover. Then we unscrew the outlet and pull it out. See, the North American outlets look like this, and these side screws are connected to live and neutral wires. So if you grab them like this, it will shock the shit out of you. So the supercap. Of course, the resistance of this wire is gonna limit the current through the supercap. I totally burned my finger. The clamp registered 376 amps, and we still have 2.2 volts on the supercap. I think we are on the right track for the jump start. First, I'm going to measure the normal current draw of the crank motor from the battery, and I'm going to use my current clamp and connect it to my scope. First, I have to set up a spot for my scope so it doesn't get dirty. There will be a Keysight scope giveaway at the end of the video. My assistant here will help me demonstrate a point while I crank the engine. You hold on to the battery contacts while I crank the car, and we measure the current on the screen. And here's 50 strokes. Wow, that was strong. Maybe around 10 kilovolts. Okay, 100 strokes. Whoa! That was like 15, 16 kilovolts. And large input AC. Okay, now I have the entire circuit, and if I connect the AC input, well, that's awful. The yellow is the AC input, the green lines is supposed to be the shifted up AC that's heavily loaded now, and the blue is supposed to be DC. Apparently the probes are heavily loading these signals because the capacitance is quite small, I think. And then I fill the PVC pipe all the way to the top of the circuit with canola oil because it's healthier, and that's all I have. Oil is a very good insulator against high voltage. In fact, high voltage switches or transformers like this car ignition coil, which I made a taser with, are filled with some sort of oil to avoid arcing between the contacts and wires. Anyway, this DC level is pretty safe on skin. Kind of zapped me. Oh yeah? No. Why is it that I die a little every time you call? Well, obviously the ringing voltage is high. Let's measure it. Well, let's give it a try. I connected my headset to a series capacitor, if you guys can see it there. And it's connected to the phone line, and I'm gonna plug it in and see if I can hear a communication. Let's dial. Oh, wait! Phew! I put 48 volts across a 16 volt capacitor. Phew! It's not even warm. Apparently the phone line can only deliver very little current, not enough to blow up my capacitor. Now let's design. And here is the circuit I designed. The phone in again. So far pretty eventless. Let's call home. Okay. It seems like everything is in order. The circuit is not warm. Everything is good. Stupid lamp, where did this come from? Now here's the machine. There is a belt that rotates very fast and constantly rubs against some rod and becomes charged. My belt is one of those workout elastic bands. The PVC pipe turns negative and the belt turns positive. Thicker pipe. Now I put that piece in the belt and stretch the belt a little bit and attach it around here. I shouldn't have glued it. See? The stupid glue settles quick and I don't have time to make it straight. Damn it. The more I'm running this belt, the more it's developing a problem. See, the PVC is getting darker and it's covered with some sort of brownish goo that I can't clean up. But the goo is kind of sticky and results in the belt not being able to rotate freely. So I just glued a bump on the side to stop it from shifting. It should be good now. Let's see. There you go. But the real question is, can it make static electricity? Oh, there you go. Very good. Oh yeah. It barely makes any static electricity now. This whole business of PVC pipe and pantyhose and rubber belt is quite temporary. I may just switch back to pantyhose and make sure it doesn't get caught in shit. Now this is a pantyhose protector. And I'm gonna make a ground ball by taping 2 more IKEA balls together and tape a wire to it and just mount it on a PVC pipe. On the internet for sure, and provide information to people so they won't believe it. One type of video are the people who claim that they have special powers, like they are immune to electricity. Like for example, this guy claims that he can pass a lot of electricity through his body. Next person, kind of the same, he claims that he can tolerate lots of electrical voltages. They don't claim they're magicians, that's the problem. If they were saying that I'm a magician, that would be fine. But they're going on TV and everywhere saying that I have this special power. So the problem with these people is that they're all fake. I'm sorry to tell you that you are not special. If you run a certain amount of current through your body, you will definitely die, right? So don't believe these people. Don't go and try and say, okay, maybe I'm special, let's try it, and then poof. Yeah. That's one thing to make sure. So what I'm going to do is that I'm going to have live wires. My breaker didn't pop. Good. So let's check it again to make sure that it's live. Welded. Damn it. I should pull it out. It's fine. Let me show you. Here I have my unloaded microwave transformer connected to 120 volt AC, and if I measure the current going in, it's around 5.5 amps, although I'm not powering anything from it. WTF? It's because I'm placing the... Now to make it a DC, all we need to do is to connect the capacitor across the loop. Always pick a properly rated capacitor for your voltages. Now if I connect it in, you see that the light goes brighter. Especially in the kitchen, they bring 2 phases to the outlet. And to do so, if you look here carefully, they have to cut that tiny bridge. Then we, what was it called? Nudify around a centimeter length of the wire. I don't know if I get demonetized if I show naked wires. Then we just push these wires into the hole. Capacitor or the circuit. I'm going to discharge the capacitor with a low gauge wire to limit the current. Wow, this thing can deliver. Done. Now let's charge this capacitor bank to 14 volts like a fully charged battery. As I suspected, even if you hold on to the wires that carry a lot of current, you won't be electrocuted.
So you weren't sure?
Ow, you little... Of course, make a high voltage, high capacity, low ESR capacitor, and for that I bought this, which is a desk cover made of material. I suppose it's some sort of mylar or something. I cut 2 sheets out of it and hopefully there are no punctures on it, otherwise the high voltage will always find a way and arc through and ruin the voltage rating. Back and power it up. Ooh, do you hear the crackling noises? Let me bring my microphone close. Oh my god, whew. That's the sound of the high voltage charges running away. Eventually, stage the arcs jump this far. At the second stage, the arcs jump a shorter distance, but there is more current. On the first stage, it's even shorter, but much more current. And at the input, well, you get the point. Now oh, look at that! That's a lot of spray. It's peeing all over the room. It's funny when I bring it close, see, it disturbs the surface of the oil. And even without touching, see, the oil is just shooting out. Look at this. Isn't it beautiful? I don't think I even need this ground cup. It just flows out. Look at my ball. So why the oil can amplify the signal a little bit. Hello, hello, hello. Ooh. It seems like the signal coming from the phone is around a maximum of 3 volts peak to peak. And from the cell phone, hello, 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 is maximum around 1 volt peak to peak. So as you see, both voices run on the same signal, and to capture this I just need to send the one signal into my circuit. Last thing I want is for my camera to blow up. Now let's check with an actual microphone to see what kind of audio voltage levels we are dealing with. Right now I set the microphone to its maximum gain, so what you see here is actually pretty loud and is around 1 volt peak to peak. And if I yell into it, ho ho ho, those voltage levels are already much higher than what I saw on the phone line, which means I can probably safely send those signals directly to my camera. And all I need to do is to start recording. And hello, hello? What happened there? Hello, hello, hello? What the hell? Why is the camera outputting some DC voltage when recording? Hello, hello? Damn it! My circuit diodes are gonna clamp that. No biggie, I guess I'll just add another capacitor here to isolate the DC from the camera from the circuit. It's just another capacitor. Okay, let's plug it in. It took a long time. Wow! I hope you appreciate my sacrifice for consistency. What I'm trying to do is that instead of a fixed PVC pipe on the top, I'm making a rotating one by putting a pipe here, and then this guy can just rotate around it. There will be much less rubbing between the PVC and the belt, but I'm still hoping that it makes decent static electricity. Okay. Well, let's give it a try. Ow, 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 ouch. It's actually better than the, ouch, pantyhose. Ah, this is shaving the shit out of my PVC pipe. This is driving me crazy. This took me 6 hours to make. It better work. And here's our ground ball. And finally it's done. What time is it? Yeah, it took me around a week and a half. Well, it seems to be working fine, just that the motor is a bit too noisy and I have a feeling my rubber band was creating more static electricity and the pantyhose will probably wear out soon. See what the phone line is made of. I plug in this phone cable and I have it exposed on the other side. The two lines are called tip and ring, and as you can see there is 48 volt DC on them, which is a pretty harmless voltage. It hurts! Alright, I did check 5 years ago that I can't take more than 12 volts on my tongue. But back in Iran, we had this building cleaner guy who was trying to help me find the live telephone lines by putting it on his tongue. And his reaction was like, "Meh." It was nowhere as painful looking as it actually is. He set a bad example. Never set a bad example. There are idiots out there that will try what you did and will hurt themselves. It's charged enough, there should be an arc between them. Okay, let's do it. Oh, well, it does get charged. There you go. But I think with this setup, it's only charging to a limited voltage. So let's room is now covered in dust and garbage and who's gonna clean all this? Now it may look like that it took me 5 minutes to put this together because I'm wearing the same shirt. But the fact is that it took me a whole week to put this together. So you better like, share, sub. After running it for a while, my pantyhose got cut in a crack and was torn apart. Thanks a lot, DIY trying. I have to go back to using my belt. They know about electricity. They know these are all tricks that you can do or swap. Never try to do what I'm doing here. And I've been zapped enough, so for this experiment, I need a victim. Volunteer. Volunteer. Hey, he has my shirt, so you come. What's your name, sir? Oliver. Steve? Oliver. Yeah, Steve. Oliver. So what we're going to do is that I have this wire here that has exposed ends, and I'm going to plug it in. And what happens is that, plug it in if I can. It hit me in the face. So yeah, when you have exposed wires, you have to make sure that the ends are not touching. Hi, after the painstaking process of
Painstaking.
Fine. After the painstaking process of explaining and putting the Van de Graaff machine together in my last video, I can freely experiment with it now. Ow! Ouch! Ouch! Well, I don't have much hair, but look at it. Ouch! Ouch! Oh, it was painful. Create. Okay, I'm doing it. Oh, finally. They had glued all the threads together. I was hoping I could take it out cleaner, but hopefully I can reuse it. And of course, because it's pretty high frequency, it should just burn. Let's give it a try. Ouch! A lot of charges are running away from the sharp points. Oh my god, my shirt is hugging me. Whoop. The problem with this right now is that the charges run out of every sharp point in the circuit and the voltage doesn't get bigger at the end. There you go. Now I just fill it with epoxy. One last time we check before we fill the whole thing with epoxy to see if the circuit is functional. You see all that noise coming from my table? Ouch! Oh, it was painful. That's a data line, isn't it? Oh, jeez. Okay, again. I'm gonna zap as many. Ouch! There we are.
It's working.
It's working. Damn it! Charge me up. We are gonna kill it one way or another. Oh, where's the ground? The ground is. Ouch!
You had to know that was happening. Come on.
I sometimes forget. Ouch! My God. Why do we have to do this?
Well, we don't have to.
But we have the opportunity. I'm going. Ouch! Well, it doesn't make any sound anymore. Is it charged? Ouch! See if I charge myself with it. I'll be discharging to the drywall. Ow! It burns. Well, I don't have much hair, but look at it. Ouch! I have a grounded ball here and some balloon party strings. Let's see if I can bring them to life. The stupid string is conductive, isn't it? And it touched the ground. Well, I don't have much hair myself, but Miss Vanda the Vandograph can give us a hand. I just touch the ground here and bring her to life with my magic wand. There! Dance for me! Oh sh**. My light! I have to find a new one now. I suppose I could touch the wand to the ground and do this with my hand. Hey! There you go. Come on, Vanda. Don't be like that. I'm not seeing Wanda. And here's Miss Vanda's ball trick. Ouch! Yeah, let's just do it directly. What, is it too powerful? Oh, I don't even need to turn it on for this to happen. This thing is awesome! Zap you! Zap you! Oh, apparently I killed electronics in my adjustable table. Don't zap this and that with your magic wand. Here's a washer I want to use as anode. Okay, here's the anode and cathode. Let's turn it on and see if I can see any faint trace of electrons jumping between them. I can hear it, but I don't see anything. It might just be the distance between... High voltage, man. It gets you when you least expect it. Okay, let's try again. I'm gonna change the gap between the two and see what happens. Oh, see? There is a tiny bit of corona discharge. Oops. Maybe not that close. I feel a wind blowing on my hand through that hole there. What's going on? Someone is not happy down there. Let me show you the wind. See? Oh, it even puts the fire out. The wind is so strong. Ow! It burned my finger. Okay, I need one of these long type. Ow! Why is it shocking me? Ow! Ouch! Oh, it was painful. That's a data line, isn't it? Oh, jeez. Okay, again. I'm gonna zap as many. Ouch! There we are.
It's working.
It's working. Damn it! Charge me up. We are gonna kill it one way or another. Oh, where's the ground? The ground is... Ouch!
You had to know that was happening. Come on.
I sometimes forget. Ready? Oh my god, it's pushing me back. So much power. I have a tiny capacitor and I'm thinking I should be able to charge it wirelessly, holding it in front of this, and then when the voltage is high enough, it will arc between the legs. Let's give it a try. It scared me. Let's try it again. Ow! One of those times it arced through my body. Ow! Jeez, this capacitor's all charged. Let me show you the wind using a flame. Ready? Ow! Jeez! Because I'm touching the circuit, the electricity goes through my hand and back to the circuit and zaps me. You know, I'm gonna clamp this switch on so I wouldn't have to touch the circuit, and then I'll show you. There we are. Things are clicking in my room. My light turned off. I have to turn this off. Ouch! What the? Ow! Ow! What's going on? I can't turn off the... Why is it shocking me? Look at this. When I'm sitting close to it, not touching the ground, my body is picking up charge. Ouch! And when I touch the ground, it sends a shock through my body. Okay, let's try it out. I feel the full force of it on my body. I think I was right, guys. Here, look at my shirt. Much wind. And it's finally done. Cue the belt finish music. Okay, let's turn it on and see what it does. You hear the power going out of it? When I point it at things, they start clicking right away. We have some of these silver leaves here I like to try. Fly away! Oh, he's stuck to the ceiling. Ouch! I have to be careful with the output, you know. Now I can join the Society of Magicians. Repello! Using my circuit that creates... Clearly I haven't learned my lesson. Damn it. Burn my skin too. Handling high voltage is very dangerous and can easily kill you if you don't have a horseshoe up your butt. Maybe that's why I can't sit comfortably. Should just take a moment. What the f? See, now the capacitor can't handle the high voltage at all. What is that? Yay! This is interesting. See, the charges are flying over air due to corona discharge, charging the capacitor enough for it to break down and repeat periodically. Yeah, Well, this was the same thing, just much faster. I guess I can increase the gap between the legs so that the capacitor can charge to a higher voltage. Turn off the supply first. Capacitors hold charge and can shock you badly. Shoo! Nothing? I can hear the high voltage. Maybe my gaps are too wide. I can raise the power supply to give it more voltage output. What's going on? Hey, I have some at the output. Still jumped across the resistors. I think I have to make my gap shorter. I made my gaps shorter now. There you go. Can I make it wider now? What? Start jumping across the resistors, but that's large. Here's the room a bit darker. God, this is loud. That's not bad. Sometimes it jumps across the resistors though. Higher voltage. This jump. Oh, what happened? Starting to continuously arc.
Ouch! My God. Why do we have to do this?
Well, we don't have to.
But we have the opportunity. I'm going. Ouch! 1000 volts?
It's 1000 volts.
It's 1000 volts, right? Okay. Yeah. Okay, now I'm gonna just touch the whole.
Oh, the voltage is way more! No, so Are you not done yet?
No, I'm gonna kill it no matter what. Okay, that's it.
Yeah, it was totally unnecessary. Okay.
Hey! Maybe I need to adjust the gaps again. I would say the polyurethane had a bad effect on it. I wouldn't add it next time. There we go. It is still pretty big. It's beautiful. Let's measure the current too. It's not making a good contact. This gap is quite wide. Let me measure it for you.
Well, you know, metal is generally conducting.
10 amps through a regular pencil's graphite. Wow, this is getting. Oh my god! Whoa! Oh! Okay, it's definitely shorted. Let's plug it in. Hopefully nothing will happen and I'll know. Oh jeez. Wow, I better clean it up before they see it. Well, I basically ran away. The breaker for all the room outlets just popped. It should turn or vibrate. Too much voltage. Let me reduce it by my auto transformer. To tap into our oven somehow if I pull it back a little bit. Thanks to the stupid design of the outlet, I can pull it back a little bit and expose the high voltage lines. Let's see what voltage we... Ow! What the f was that? Stepped on stupid spaghetti down here. I have to clean it up. Okay, let's do it. It will show us if the phases are 120 degrees out or 180 degrees out. Let's check. Holy piece of... This is super sketchy, but let's see if it works. Woo. Okay, and we'll bond over playing these games. So here's the jack-in-the-box contraption. You just turn it on, and anyone touches the handle will be shocked. In some of the outlets, especially in the kitchen, they bring two phases to the outlet. And to do so, if you look here carefully, they have to cut that tiny bridge. Always wear safety gloves to protect your fingers and don't try this at home. Let me see if I can make some arcs. Always wear safety goggles when dealing with very bright arcs. Let's try it again. Nice, look at that. Nice. Am I on fire? Okay, ready? Capacitance of the MOSFET by touching the positive and negative lines through my body. And now the relay can turn on a light too. I stick an AA battery. Let's see how badly it shocks. I hate getting shocked. Ow! This is pretty painful too. Let's try it one more time. Ow! Ow! I hate it. Let's try it one more time. It's really experienced one. What this? Ow! It burn freezes. There you go, 100 amps. And it's holding on pretty. Oh, my auto transformer can't take that much power. And feed some material through. You see the LEDs start to get red as the head hits. Let me demonstrate. I plug it in and now the rails are live, so under no circumstances you should touch the rails. Now I put the projectile on. Look at that, people. Molten... Oh, this glove is not good for this purpose. And remember that the white wire is neutral, and that's where you would be connecting your program. The white wire was neutral. I connected it backwards. I'm measuring the capacitor voltage and it's around... It's not gonna heat up because it's plastic. Now if I turn it on, it draws power from the supply to heat up the... How does it work? Wow. If there is metal in something, don't put it in the microwave. More turns to get high enough voltage. And here is my handicraft. Let's measure and see where we are. It's higher. As you know, a speaker is a magnet and a coil that when you excite the coil with an AC voltage, it vibrates at the same frequency.
The first thing you need to do is to unscrew the head and rotate it and mount it on the tail by piercing into the tail. Well, never pierce a hole towards your body. This tail is a little bit tough, so I'm going to drill a hole into it. It's much more dangerous if the current runs through your body first, then into the water. Let's try it. Well, that was super painful, not even compatible to if you just put the spoon in the water. Ouch! Then there's a node around here, then it's vibrating here. Let me increase the amplitude so the vibrations are more visible. Oh, and we will hammer the head into the wood like this.
Here you go, son.
Thanks, Dad.
Holy shit!
I made this simple circuit and I'll plug it in. Now the circuit is hot and the voltage is on this. I put the meter on AC and I measure the voltage. Oh my God!
Let's cut the stupid LED out to reduce the current draw a bit. Yeah, I guess the LED wasn't drawing much. So that's it. 100 milliamp is the magnet. Watch the current carefully as I connect the capacitor.
Anywhere, the arcs still jump to it. The hell? Ouch! Although the arcs are... Ouch! Ouch! The arcs are not jumping to the screwdriver, but it burns my hand.
Connect this together. Oh, it did jump. Hey! It's glowing hot here. But in a lot of cases, eddy current can be pretty bad. Ow!
What kind of sorcery is this? Did it decide not to hurt? Ow! Nope.
See some AC voltage, but because the charger output and live wire are isolated, if I short them, there is no current running between them and the AC... I tied some wires to the element terminal so I can probe them. Now if I turn on the voltage... ground wire, nothing happens. And if I touch the live... never try this at home. It is okay because I'm isolated. Okay, nothing happens. What's going on there? Something... Ow, shit! People suffering in cold mines. Loose wires. Avoid them. Oh, hey. Hey, man, take a listen to my latest mixtape on this. Ooh, let's hear it out. Backwards. Backwards again. Hurry up, caveman. There we go. It was a prank, man. You're such an idiot. You plug anything into your computer, now it's gone. You should see the look on your face right now. But I trusted you. It was just a prank, bro. Don't beat yourself up for your stupidity. My life's work was on this computer. Don't worry. It kills your USB port and likely your motherboard. What won't erase your data? Then we are good. High five. Yeah, unless you have solid state drive memory, that is. I bought this novelty gun from my local dollar store, and when you press the why? Now it's ready to go. You just plug it into the power line, it charges right away and you can unplug. Then you charge. Flash capacitor is still charged. Let's discharge it first before touching it. These things are violent. See, it doesn't arc anymore because I think the capacitor is loading the output voltage and reducing it. So I have to bring the contacts further close. Ow! Shit! Yes, ow. Okay, all the booger water is collected. Oh, there's no drain. Ah, the doors are closed. Ouch. Body a little bit and then discharge. Ow! That was painful.
Jump start again. I had charged the supercap to 14 volts, but oh something crap. What the
Live 120 volt AC input, and I have my capacitor and diode here, and I'm probing across the diode. Now if I connect the circuits together, but much more current, and at the input well, you get the point. It's like everything is in order. The circuit is not warm. Everything is good. Damn it, I zapped myself. There we go. Professional plumbing done professionally. Now the question is, does it work? Of course it does. Was there ever any doubt? And here I have the CD power line. Both of them are exactly at 120 volt AC. Like behind a red light or in a charging lane. I remove this drain to measure the water usage. Ah, why do they use this stupid bend here that only collects dirty water and booger? Something like this inductor and capacitor. This is a filter. If I try to measure the AC output using my... The power line straight capacitors don't blow up like that. Oh, the reason my light is turning on is because I'm hiding my Tesla coil under the table. Ow! What they say about AC, it hurts. Yeah. I'm stuck with 60 hertz for now. Let me see if I can charge my body. Put my legs up. Oh, I can feel my hair rising. Ow! Something zapped me right in the ass. Oh, the city voltage is a sine wave. Now if we scope it, which one was the live wire? Black is ground.
and jump start the car, and hopefully it will start, and then I disconnect everything. Ready, set, go. Damn it, nothing happened.
Some plugs like this one that we can measure. Here we have test.
What's up with my circuits and all the smoke?
In conclusion, here is how Muso works in all the modes. Let me read you a passage. Once everyone else was settled in
their old man Charles had a farm, and in his farm he had a cow,
and of course a brushless AC motor like this one that I took from an old microwave oven can last much longer than a brush. This here, I killed it. Don't short. Anyways, with this, I'm converting the AC into DC using a... it's a single diode, but it will do. And if I measure the voltage at the output... Holy f... The capacitor... Any tone from it, like this. There is 48 volt DC on them, which is a pretty harmless voltage. Wires. As we expect, we just have to tie the neutral wires to the ground of this. I have a foot switch that applies the 120 volt to my valve, like this. What the f? Realistically, I'm gonna touch the door. Ouch! Charge my body first and then let go and then touch the ground. I hate surprises.